LaTeX can be quite intimidating for beginners, but it can be equally helpful when working on large documents that involve repetitive tasks. And for chemists, one of these repetitive tasks is the numbering of the compounds in the document text and in the figures and schemes in ascending order. And I'm showing you today how you can do this in LaTeX with several chemistry packages that are very, very helpful. So I'll show you first how this example document that we're working on today will look like, and then we will go step by step through the different commands that you need for creating such a document. And as a little disclaimer in the beginning, this is not a LaTeX introduction, so if you're not familiar with LaTeX at all, I have some links in the description below where you can get acquainted with LaTeX if you're a complete novice. So this is more an advanced course if you already understand the basics of LaTeX and if you are familiar with the basic commands in it. So first of all, what you need is a LaTeX editor. So I'm using Text Studio for this tutorial here, and I've also used it for writing my entire PhD thesis, and I'm extremely satisfied with it. I had zero problems for several hundred pages document with a lot of figures and schemes. It compiled reasonably fast, and it was also very, very user-friendly. It is available on all platforms, on Windows, Mac, Linux, etc. And it is for free, it's open source, so you can download it for sure on your device as well. And besides a LaTeX editor, you will need the figures and schemes that you want to use in your LaTeX document in a very special format. And this file format is a so-called EPS file, which is an encapsulated PostScript file, and you can generate this in, for instance, in CorelDRAW, which is a vector art software. And the reason why you need to export it, the images and figures and schemes as the EPS files, is that the text, it can still be exported as text and is not rendered as a vector graphic. As you can see here, if I open this .eps file, it gets converted to a PDF in Mac, but don't worry, it's getting saved as a PDF. You still have the EPS file. It just needs to convert it temporarily into a PDF so that you can view it in your image viewer software. You can see I can select here the text, even the text here in the Lewis structure, and also these labels here that I've already prepared. And I'm going to show you also all the other figures that I have prepared. So let's imagine I have two figures and one scheme in my document, and I would like to use them in my LaTeX document, in my report, or whatever I'm going to do. So what you need to do is to prepare your figures and schemes as you would prepare them as usual, and you need to replace these compound numbers that you would usually place here with these temporary labels. So what I do is I label them as TMP001 for the first compound, and then I go up with one digit for the next compound, and here I have these sub-labels here that I want to render in the end as 3A and 3B, or 20A and 20B, whatever. And also on this figure here, I have these 4 TMP labels that you can see here. The important thing is that you export all these figures and schemes as .eps file. So you can do this from ChemDraw, but there you can run into the problem that ChemDraw doesn't export it as PostScript 3, but as a PostScript 2 file, and this is not supported by these chemistry packages that we're going to use. So make sure that you have a software that allows the export of PostScript 3 files. You can do this with CorelDRAW, I'm not sure if it's possible with the free software called Inkscape, which is also quite a good vector graphics tool, but you can try it on your own if you can export it as a PostScript 3 document and not as a PostScript 2 document. I know that CorelDRAW is able to export files as PostScript 3 files, as EPS files, which is needed for the use in this tutorial. So what you can do, you can export your ChemDraw files as PostScript 2 EPS file, and then you have to import them into CorelDRAW again and export them again as a PostScript 3 file, which is a little bit complicated, I know, but if you don't have to change anything in your scheme anymore afterwards, you will never have to open this ChemDraw anymore, because the numbering of the figures will be done automatically by LaTeX in the end. So you're still saving time, even though you have to import your ChemDraw exports into CorelDRAW and export them as a PostScript 3 file. So what we have here is these 3 figures and schemes that are exported as EPS files with the PostScript 3, and the text is exported as text, so you can select it. And this is important because LaTeX needs to edit these labels later on. I would recommend that you create an Excel file or a text file where you put all these labels in a table so that you don't lose your overview on the topic, and you put the labels here, the TMP labels here. Then you need to create another label. For instance, if this is an ester, you can maybe label it an ester or whatever you want. And here we have a Claisen product, so I'm calling it Claisen product, as boring as this is. You can choose whatever you want. And then the third compound is just aromatic A, and because I want these labels to be the same number, but they differ in their sub-label letter, so this is going to be number A and this is going to be the same number B. That's why I give them the same label here, and they have a different sub-label, but we will get to that a little bit later. But this is how you should prepare your document, and you should keep track of your labels in an Excel file or a text document. So these are the things you need: the LaTeX editor and your files in EPS format. And let's now go to this document, and I'm going to show you first how the final document will look like, and then we go through all the commands and look how they work more or less. So we start with the title page. Name of this video: how to chemical compound numbering in LaTeX, and this is my name, and this is the date, which is not quite right, but it doesn't matter at this point. And then we have this document here. We have the first scheme here and a text that has these labels here. And ester 1, this is this compound here, gets converted into a Claisen condensation product 2, which is this compound here, in scheme 1. And then we have in the scheme also these numbers that are matching with the numbers in the text. As you remember, we had here these temporary labels over here that have now been replaced by LaTeX into the corresponding correct number in ascending order. Obviously here, these numbers here match with the numbers over there, but it doesn't necessarily have to. This is just because in this example, the setup is extremely simple, but I'm sure in your thesis or whatever you're working on, your compound numbering is a little bit more complicated than in this document here. So what we can see is the LaTeX has replaced these numbers or these temporary labels with the right correct number for all of these figures and schemes. And then we also see here the sublabels that work as well. So we have in the text, benzene is 3A and toluene is 3B, which is correct also in this figure over here. This works also for these spectra. As you can see, we have here 4 spectra in this graph of these for compounds. Obviously, these are imaginary spectra that I have just drawn, but this is just as an example. And you see here also we had these temporary labels over here, and now they have been replaced by their corresponding correct number. So this is how this works. This is how this very simple document looks like. So let's now see how we need to set this up so that it works in the end when we compile it. So what we usually start with in a LaTeX document is the document class. I have chosen the article class on a A4 paper size with an 11-point font size. And then we use the hyperref setup. This makes the compound numbers clickable. So you can see if I click here on compound number 1, it will bring me to the very first instance in the text. So it's easier to find the structures when I'm later in the document and I need to recall what this structure here looks like. And this is quite handy also in the final PDF that you will render from the LaTeX build. And with this hyper setup command here and all these arguments set to black, these links will all show up black and not with some weird background colors and borders. I'm gonna uncomment this real quick and I'm gonna render it. So as you can see, it has these red borders around it, which doesn't look very nice. That's why I have used this hyper setup command to make this all look a little bit nicer. And then these two packages here, the input-enc and font-enc package, are required for inputting international characters. I recommend using these if you, for instance, want to use umlauts, etc. And I'm also using usually French spacing. This has nothing to do with these chemistry packages, but it will remove these large gaps between these full stops and a new sentence, which is not very modern anymore. That's why I commonly use the French spacing command. And then we use the graphic_x package, which adds figures to a document, and the caption package, which returns the figure 1 and scheme 1 labels here in small caps if you use this argument label font is equal to SC, which stands for small caps. And then I'm also using the first chemistry package in this document, the bpchem package. This is used for converting these temporary compound labels in the paragraph text. Here, for instance, this one, into the corresponding compound labels in the final document in ascending orders. And we'll get to that, how you can write such a command in the text a little bit later. And then the next two chemistry packages that we are using is chemstyle and chemscheme. The chemstyle package is just a general package for formatting chemical documents, and the chemscheme kind of belongs to this package. And the chemscheme package is used to convert these TMPXXX labels in the figures and schemes into the corresponding compound labels. So this is what is written here. It takes this TMP004 label and it returns it into the correct sublabel. In this case, it's the 3B label that is needed in this case. And with this declare robust command, we solve a problem that encounters sometimes with sublabels because it puts too many spaces between in between these labels, which is kind of ugly. So I'm using this command here to fix this. So you see, sometimes LaTeX can be a little bit buggy, but it is still quite useful if you know how to use these fix commands here. And with the helvet package, this makes the schemes and figures or the labels in the schemes and figures a bold non-serif font. I'm going to show you how this would look if we wouldn't use that. I'm going to comment it out. And if I render it, yeah, it doesn't look very nice. And if I comment it again, we have this nice bold text, which is what you would expect also in every other chemistry document. And the MathPasso package just uses the Palatino font by default, which I think is quite nice font for scientific documents anyway. So I'm going to use this in general when I'm working with LaTeX. And then before we come to the actual part of the document, I need to declare a title of the document, which will be shown here, and my name and the date, which we have covered before. And then we can begin the document and begin the title page, make the title. This prints all these items here. And with this page style curly brackets empty, this just removes the page number on the title page, which I don't want. And then we are finished with the title page and we get to this document. So now you can see what I've done here finally. So you see I've written an ester, which is also shown here, of course. And then we start with the bracket, and then I write this command here, \CNlabel curly brackets ester. And we can remember in my table here, I have given this first compound this label called ester because it's my only, or the first ester in this document here. Obviously, this is also an ester, but whatever. And I'm always going to use this label whenever I want to call this compound here. So also later in the text, if I'm referring to this compound, I'm using this label here, CNlabel curly brackets ester. And this gets automatically converted by the bpchem package into number 1 because it's the first label that appears in the overall document. So and this gets converted into this Claisen condensation product. And then I have another label, which is called CNlabel curly brackets Claisen product, and this is then rendered as a number 2 because it's the second compound number in the whole document. And this goes on obviously, and here we have a reference to the scheme, which can also be called. I have here the commands for creating the scheme. So I'm using centering, and then I am calling another command here. It's called schemeref command, and this is now used for converting this temporary label that we had seen here, this TMP001 label, into the corresponding label so that this one fits with this number here. And what we need to do for that is we put a not a curly bracket, but a square bracket here. And we use the temporary label that is in the figure or scheme that we are going to use in this scheme. And behind that, we are giving it the curly bracket command that we also used in the text, so that the chemscheme package and the bpchem package can communicate with one another, and we can tell the LaTeX engine basically that these two labels should belong together. This can be a little bit confusing in the beginning, but if you're following this recipe with this table here, so where you see all the corresponding labels together, this will become quite easy after you have done it a couple of times. And we also need to call the second compound here, obviously. So we also have the \schemeref command in square bracket TMP002, and then the curly brackets command that we've also used in the paragraph text. And then we obviously include the graphics with the right path figures \scheme1. I'm giving it a caption. And here, as you can see, I'm not using the CNlabel command like I did before for calling this number here, but I'm using the \CNref command. And I'm doing this because this is done in a caption, and I don't want this number to overwrite this number in case the scheme would be placed in front of this text over here. So this can be a little bit confusing because here everything is in the right order, but imagine that all these schemes and figures are above the paragraph text. What would happen is the labels in the figure caption here would possibly override any number that would appear in the paragraph text, and what we want is the ascending order only to be in the paragraph text and not being influenced by the schemes and figures. So this is a little bit complicated, but also I would recommend to just use this recipe that I'm telling you. Never use the CNlabel commands in the captions of schemes and figures, but always use \CNref and then the same label here as you use in the paragraph text. The output will be the same. It will also be rendered as a 1, but you will not run into issues in case your schemes and figures are a little bit in a different position from the paragraph text. So just keep this in mind and do it like this, even if you don't understand it right away. I think it will get clear if you play around with it a little bit. And obviously I'm also calling this compound here, so I'm also using the \CNref command Clason product in the caption text instead of the CNlabel command that I've used up here. And then I give the scheme a label too, obviously. Label SC stands for scheme colon scheme1, and so that I can call it here again. Okay, so this has been the first scheme, and now let's look at the sublabels that can also be done with the bpchem package and also the chemscheme package. So this is the text that is written here, so also sublabels can be used. See figure 1, which is here for an example, and figure 1 shows benzene, which is 3A, and toluene 3B, and the commands for using sublabels is pretty similar to above, but what you need to do is using the CNlabelsub command instead of only the CNlabel command, and here you have two curly brackets called aromatic A and aromatic B, so that they will show up like this in your document. So simple as that. Just use this recipe again that I'm showing you to do sublabels, and the same can be done in a figure or in a scheme. It works both in schemes and figures. It doesn't really matter which you use. But you need to use the command schemerefsub instead of only schemeref if you want to work with sublabels 3A and 3B. If you are want to convert these temporary labels that we have seen in this figure over here, the TMP003 and 004, into these 3A and 3B labels. And the same goes for the caption for sublabels. Don't use CNlabelsub here, like in the paragraph text, but use CNrefsub here for using them in the caption. The output will be also 3A and 3B, but you won't run into any issues if your figures appear in a different position of your document. Also, this is important if you're using a list of figures and list of schemes in your beginning of your document, because then the ascending order would start already probably in the list of schemes and list of figures, and the ascending order wouldn't be correct in your main document. So this is important to keep in mind. Never use CNlabel command or the CNlabelsub command in the caption, but always use CNref or CNrefsub. So, and lastly, as I told you before, we don't even need a chemical structure in our figures. We can also use these same commands and same labels in just a spectrum, for instance, if you want to label the different spectra of a plot, and this will then turn out like this. As you can see, this is what I've exported from my ChemDraw document as a PostScript 3 EPS file, and this is what LaTeX has done after compiling my document. And here we have also all these commands here that are listed again, the schemeref commands and the schemerefsub commands. for the sublabels, and also the caption labels here all listed in the right order. So this is already all what you basically need to know to use LaTeX to automatically number your chemical compounds in ascending order in your documents. It's very, very handy. Just keep in mind you need to write software to export your EPS files that is able to create PostScript 3 EPS files, because PostScript 2 EPS files generally don't tend to work, and this can get quite messy otherwise. So just keep this in mind. That's the most important thing to know. Apart from that, you can just use this template here. I will upload it to GitHub, and you can download it and look at it and figure out whether you can work with that, or whether something is unclear. If something is unclear, leave a comment in the comment section below. I am trying to answer them, or maybe someone else is able to help you. I think this is also a really nice opportunity to help each other if I don't have the time to answer to all the questions below. Another important thing that you need to keep in mind is the right settings for the build, for the compiling. So if you're opening the Text Studio settings and go to the Build tab, there are these two settings here that you need to change, most probably the build and view setting and the default compiler setting. I tend to use the DVI PS PDF chain for the compiling of such documents that involve the chemscheme package, because otherwise it wouldn't work. And I'm also using the LaTeX compiler and not, for instance, the PDF LaTeX compiler. And with these settings, if you take a screenshot here, it's quite sure that the compilation works and all the numbers get converted into the right final label in all the schemes and figures and in the paragraph text correctly. So this is how I've done it in my PhD thesis, which was a little bit longer than this document here, and it worked very well until the end. So this is it from me today. I hope you enjoyed watching this video and you learned something, and if so, please leave a like and comment and subscribe. It helps me a lot as a content creator, and it keeps you updated about my future uploads. I hope you have a great day, a great week, and I wish you all the best. See you next time.